All right, boys and girls, today we're going to talk about work, power, and energy. Our learning targets for today is that I can explain what energy is and that I can explain how energy, work, and power are related. Okay, so what is energy? Energy is the ability to do work or cause change. Here we see the dog pushing the cart. We know that the dog is doing work on the cart because he's applying a force and the cart is moving in that direction. In order to do work, we need to have energy. Energy is what allows us to do work. Energy makes stuff do stuff. Okay, so in the video we just saw, we saw the dog doing work on the cart. Well, when the dog is doing work, he's using energy. And as he's pushing that cart, he is transferring some of his energy to the cart. So how are energy, work, and power related? When you do work on an object, energy is transferred to that object, and that object gains energy. So we know that work is when you apply a force and that object moves in the same direction as the force applied. But we can also say that work is the transfer of energy. We know that power is how much work is done in a certain amount of time. If work is also the transfer of energy, we can then say that power is how much energy is transferred in a certain amount of time. So therefore, power is the rate of energy transfer as well. Here we see two pictures. Work needs to be done here. We've got snow and it needs to be moved. Both of the people can do work on the snow. The little boy can shovel it and the man is using the snowblower to do work on the snow. Now, both of them can do the same amount of work. However, the snowblower is going to get the work done in a lot less time. Therefore, the snowblower has more power and is transferring energy faster than the little boy. Complete figure 1 on page 109 in your textbook. Go ahead and pause the video if you need to. The snowblower has more power than the person with the hand shovel. You could use an elevator or the stairs to lift a box to the 10th floor. Which has greater power? Why? An elevator has more power than you taking the stairs because it can lift the box faster. What are the two main types of energy? Well, there are two main types. They're kinetic and potential. Let's talk about kinetic energy first. Kinetic energy is the energy an object has due to its motion. The formula for calculating kinetic energy is 1/2 times mass times speed squared. So we can see that mass and speed affect how much kinetic energy we have. The more mass there is, the more kinetic energy. The more speed there is, the more kinetic energy. Let's do an example together. A boy is pulling a 10-kilogram wagon at a speed of 1 meter per second. Calculate the kinetic energy of the wagon. Well, first we have to look and see what are our mass and our speed. So here we have a 10-kilogram wagon and the speed is 1 meter per second. We need to set up our equation. 1/2 times mass, which is 10 kilograms, times the speed squared. I'm going to put the speed in parentheses because I'm squaring the whole entire speed, not just the unit. All right, so I have 1/2 times 10 kilograms times 1 squared. 1/2 times 10 times 1. So we get 5. The units I'm left with is kilograms times meters squared per second squared. Now that's kind of an odd unit, and it turns out that we're going to just call that a joule. We'll use an SI. We'll call kilograms times meters squared per second squared a joule. So we can say that the wagon has a kinetic energy of 5 joules. Notice that the energy unit is the same as the work unit. Complete the do the math on page 111. Go ahead and pause the video if you need to complete it. A girl and her dog are running. The dog has a mass of 20 kilograms. The girl has a mass of 60 kilograms. Number 1, suppose both the dog and the girl run at a speed of 2 meters per second. Calculate both of their kinetic energies. So for the dog, we're going to calculate 1/2 times 20 kilograms times 2 meters per second. For the girl, it's going to be 1/2 times 60 kilograms times 2 meters per second. Our kinetic energy for the girl, oh, and I forgot to square. Don't forget to square the speed. Our kinetic energy for the girl is, for the dog, I'm sorry, is 40 joules, and for the girl is 120 joules. Number 2, suppose the dog speeds up and is now running at a speed of 4 meters per second. Calculate the dog's kinetic energy. Well, we have to do the same formula, 1/2 times mass, 20 kilograms, but this time the dog is running at 4 meters per second, and I'm not going to forget to square that this time. So 4 squared is 16 times 20 times 1/2, we're going to get 160 joules. Number 3, are your answers to question 1 and 2 reasonable? Explain. Yes, it makes sense that even though for number 1, the girl and the dog are running at the same speed, they have different kinetic energies. The reason that is because the girl has more mass than the dog. And then for number 2, doubling the speed of the dog quadruples its kinetic energy because we have speed squared. So doubling it would be quadrupling it because 2 squared is 4. So it's 4 times as much. His speed is 4 times as much when we double the speed. The other form of energy is potential energy. Potential energy is energy that results from the position or shape of an object. The first type of potential energy is gravitational potential energy. This is energy due to an object's height. The formula for gravitational potential energy is weight times height. Let's do an example. A 10-Newton book is lifted 2 meters off the ground. We need to know the weight. We've got 10 newtons, and we need to know the height. That's 2 meters. Let's fill in our information. Weight times height, 10 newtons times 2 meters equals 20 Newton meters, which we know is the same as 20 joules. So our answer, the gravitational potential energy is 20 joules. Complete figure 3 on page 112. The rock climbers have gravitational potential energy. Use the diagram to answer the questions. Circle the rock climber with the greatest potential energy. Well, that would be this person right here because he has the most mass and the highest up. There's a person down below that has a similar weight, but this person is higher up. So calculate this potential energy. We would do weight times height, so 600 newtons times, let's see, he's at 4 meters. We're going to go from the lowest spot on his body, 4 meters. 600 newtons times 4 meters would give us 2,400 Newton meters or joules. Number 2, where would the rock climbers at the top have to be to have half as much potential energy? If we want to have half as much potential energy, we would have to be half the height. The other form of potential energy is elastic potential energy. Elastic potential energy is energy associated with an object's shape. It's associated with objects that can be compressed or stretched. For example, a stretched rubber band or a compressed spring. These things have potential energy because they want to go back to their normal shape. When we stretch them out, they want to go back to their normal shape, and if we let them do that, they can do work. So these are types of elastic potential energy. Okay, go ahead and complete the Assess Your Understanding on page 113. We'll check over these together in class.